Unit 7, Day 3 homework tutorial. I will work with you on the even problems and then just mimic what I do on the even problems for the evens. I will work with you on the odd problems and what I do with the odd problems, mimic on the even. Alrighty, so we're using inverse trigonometry to find the angle measures. So let me get my pen. Here's my reference angle, theta. And according to where theta is located, side 12 is the adjacent side. And side 13, since it's across from the right angle, is your hypotenuse. So since I have adjacent and a hypotenuse, I can set up a cosine ratio, where it would be the cosine of theta. Theta is a Greek letter, so it's basically x, it's variable. Cosine of theta is equal to adjacent, which is 12, over hypotenuse, which is 13. Now we talked about it in class. In order to remove the cosine from in front of the theta, you have to apply the inverse to both sides. So they would cancel each other out. So cosine inverse will cancel out cosine, leaving theta is equivalent to the cosine inverse of 12 over 13. So now when you grab your calculator, you would type in cosine inverse by hitting second first, and then your fraction. And if done correctly, you would receive 22.6 degrees for theta. I want to see, as for work shown, everything that I presented for you on your own papers in order to get full credit. Again, I repeat, show everything that I have shown to receive full credit. And let the layout and the flow line up your equal signs just as I have done. All right, let's work on the next one, number 3. Theta is down here in this corner. And since that is theta, I have the adjacent side again, which is 6. And then I have the hypotenuse, which is 9. So I can use cosine again. Cosine of theta is equal to adjacent 6 over 9 hypotenuse. So I already know what step is coming next, so I can go ahead and jump right to it. I'm going to apply the cosine inverse. So my next step should say theta equals cosine inverse of 6 over 9. And then grab your calculator and insert it at the same time. Cosine inverse, 6 divided by 9 is 48.2 degrees. Don't forget your degree symbol as you were talking about angles. All right, number 5. Here's theta. I have the opposite side, which is 7.7, and then I have the adjacent side, which is 14. So that means I can use the tangent function. Tan of theta is equal to opposite, 7.7, over adjacent, which is 14. And now I apply the tan inverse to both sides to get theta isolated. So theta is going to equal tan inverse of 7.7 divided by 14, and type it in your calculator. and you get roughly 28.8 degrees. And number 7. Here's theta in the corner. You have the adjacent side and the hypotenuse. So we again have cosine of theta is equal to adjacent 4.4 over hypotenuse, which I believe is 11. Let me double check by looking at the copy, as this version is not the best. Yeah, I used 11. So now I need to apply the cosine inverse to both sides to get theta isolated. And theta is approximately 66.4 degrees. And this concludes your tutorial.